So which team is this?
This is Team 13, Makers Mafia. You guys have
All
4 minutes to present. And as soon as you say the judges, are we feeling ready?
Yeah.
All right. As soon as you guys say go, I'll start the 4 minute timer for your presentation.
Go.
Started.
All right. So I'm John Hinton.
I'm Matt Miller. I'm Michael Cheney. I'm Michael Hayes.
And our project here, let me see if I can get a good angle, is a turret that we mounted on top of an RC Nitro car. So it launches foam darts by using a double flywheel mechanism here at the front. And we have a cartridge here that we've created that can hold 8 darts at a time. The darts launch out going pretty fast. Actually, we calculated it should be around 70 miles per hour. And
Should the cartridge have closed?
yeah. Quick check. Is it on screen? I can't see it from here.
screen.
Okay.
So it's wired with stepper motors to where it should be able to pivot side to side, left and right, up to 180 degrees in each direction. Yeah,
But the plastic from the 3D print broke.
yeah, we had a problem when the 3D print didn't come out exactly right and the plastic broke, so it's dodgy on the rotation. But it's set up and the stepper motor does work by itself, and it uses a joystick, analog joystick that goes side to side to control the horizontal movement, and pressing down the joystick is supposed to fire, but the hammer does the servo isn't working either.
Okay. So we're gonna demonstrate it by manually firing a dart. We're just gonna move the hammer ourselves for this. So they get decently far down the hall, as you can see.
A lot farther than feeling.
They launch at 70 miles an hour, so
Yeah, technically we're running it at half speed right now since we're inside, so it's more like 35, but outside they can go at 70.
All right. Do you have anything else to say?
We're good. I'm good.
Yeah.
oh yeah, the mechanism with the stepper motor and the servo that controls the hammer uses a microcontroller, and that's how we link the joystick in.
Yeah, we have it all set up with the Raspberry Pi Pico.
All the electronics were theoretically going to sit back here.
Yeah,
So
basically we just came down with restraints on 3D printing speed, so
Yeah,
we couldn't put the hardware together because we were waiting on printing.
we ran out of the time to print, so it made it hard to test.
Yeah.
All right.
Yeah.
I think that's about it.
Okay, great. Now we can start the 4 minute Q&A.
Okay. Let me take this off so we can all like stand in front of this.
Hi. Very nice project. I'm wondering about your microcontroller. What controller are you using and how did you program it?
It's a Raspberry Pi Pico, and we used C++ inside the Arduino IDE. Instead, you can use MicroPython too, but I use C++ instead.
And we went with the Pi Pico because eventually we were planning to add a Bluetooth control with your phone. We just didn't have time to implement that. So it's the Pico W, so it has the Wi-Fi and Bluetooth.
Can you
Just a
describe
quick
again?
question. Oh, sorry. Yeah, go ahead. Someone else was
Sure.
asking
Can
something.
you describe again the intended application?
It's really just for recreation. I mean, we thought the idea of mounting a turret on an RC truck was something that would be really fun, so,
Personal enjoyment.
yeah.
Fair enough. Thank
Just a quick question. How do you guys plan to improve it if you want to improve it further?
Yeah, can you repeat that?
If you want to further improve it in terms of performance, what would you want to do? Like, what would you want to add to it?
Oh,
Well, we want to add the Bluetooth or infrared remote, either one, to control it, so that way it can actually work when the truck's driving. But again, we just didn't have time to implement that. And then a lot of the 3D printed, well, really just the 3D printed bracket that mounts it to the truck and controls the yaw axis is currently broken because the print failed. So we definitely want to redesign that a little bit and fix it.
yeah, and we were considering adding like a Y-axis for vertical pitch too, but I don't think we'd be able to do that with this microcontroller because I think it to run the
We'd have to use something other than stepper motors because the stepper motors have a pause function while you wait for them to make the step, so you couldn't run both stepper motors simultaneously. And also we could not source another bearing. We had to like go to the auto parts store 30 minutes away to be able to find one for the Y-axis.
yeah, that and the analog joystick to get the Y input on the joystick, it has to go through a analog to digital converter on the microcontroller, and I think there's only one at a time, so I don't think that would have worked.
Okay, got it. Thank you.
Can you talk us through some of the alternative solutions you considered before you settled on this hardware put together in this way? What were the other options you thought about, and why did you choose this versus those other ones?
Well, one of our most creative options was we were actually planning to use the gas from, or like the exhaust gas from the nitro engine to propel it, because we thought that would just be really unique. But the main reason we didn't go with that solution was because we don't have a way to guide the exhaust gases easily that would not melt. So
Yeah. On the cartridge, we initially had plans to have some sort of like either spring-loaded or elastic mechanism that would push the darts down into, you know, the firing chamber, but it ended up that we didn't need to do that because gravity alone was sufficient to get them in place to fire.
Okay, thank you.
Time is just about up. Thank you for presenting. Team 13.
Thank you.
The next team, Team 77. You have 2 minutes to set everything up.
Awesome. Let me just get my camera rolling. Okay, good. Yeah, we're having a little bit of camera difficulties. I'll keep trying to get this camera up. If not, we can just hopefully share our slideshow.
Got it.
All right. Great. And then I will go ahead and share our screen.
When you're ready, say go so I can start the timer.
Sure thing. And we actually maybe I should get this share. Yeah. Okay. And yep, we're ready.
Start it.
Cool. So we're Team 77. Our project was the Smart White Cane. My name is Balaji Kurapati.
I'm Matt.
And Court had some other commitments going on this afternoon, so he couldn't be here.
Yeah, so some current issues with existing white canes.
They are like a reliable technology, but they are effectively, just a stick. So they can't detect obstacles beyond the reach of the cane. Another issue is that there's no navigational information. So there's no like extra functionality in terms of like providing directions. And then also tying into navigational information, since there's no GPSers, or other methods of sending a distress signal, which could be important in case somebody is in distress.
Yeah, so our solution to this is a smart cane, and the idea is that we can build a new intuition and kind of safety for the visually impaired. So this is jam-packed with a whole bunch of sensors and features. One of them, or the biggest one, is the ultrasonic sensor paired with haptic feedback. So the idea is we have an ultrasonic sensor at the bottom of the cane, and as we move it around, the user gets vibration feedback at the handle. It's more intense when there's an object closer to the ultrasonic sensor at the bottom of the cane. Another big feature that we have that we're really excited about is safety alerts to inform emergency contacts. This is done by using geolocating, using Wi-Fi access points. So basically, we see what Wi-Fi networks are available nearby the cane if something was to happen. And with that, we call it a Google API that then kind of triangulated the position of the cane. Another one is an SOS button. It kind of also sends a distress signal, but by the user's input. And then kind of to gauge whether or not the user is actively using the cane, or if something might have happened and they lost contact with the cane, maybe they fell down, that kind of thing. We have a touch sensor where they can keep their thumb on top of it, and a gyroscope sensor to kind of identify the orientation of the cane, whether it's standing up, maybe it's laying down, that kind of thing. And then we have speaker implementation for future navigation features. And yeah, then we can go ahead and go through our demo video. This is our cane, and then we can show you what it does.
Yeah, and then also for future improvements, we'd like to implement true navigational directions, because we weren't able to do that in terms of like actual turn-by-turn directions based off of current location. And then also combine ultrasonic sensors with LiDAR sensors and possibly other sensors for more accurate data. So this is our demo.
If there's a sound we're supposed to be hearing, you may need to share your sound.
Oh, okay. Oh, here, maybe we'll have to stop the share and then share again with the actual screen.
Oh, that would be it.
Let us know if this makes it any better. Can you hear anything?
No, so why don't you just talk through it?
Sure. So this is where we're kind of showing how the cane can move side to side, and you can hear the vibration. It gets louder as you approach the wall, and it gets quieter as you walk away from it. Here we're kind of showing the touch sensor. So as long as you have the touch sensor enabled, or as long as you have your thumb on the touch sensor, then you'll be fine. But if you migrate from it for too long, then we'll send a text message. And that switch that you see, kind of you can toggle that feature on and off. And this is the text that you get, and it gives you a link to a Google Maps. It's a Google Maps link, and it kind of takes you to where that location is, and it gives you a rough estimate of where the user might be. And then similarly, there's a button under the tape there. That's the SOS button. It does kind of the same thing, except it's more manual input.
That's your time for your presentation. The 4-minute
Sure.
Q&A begins now.
Just a quick question. You guys talked about multiple sensors and in the future maybe introducing LiDAR sensors and such. But like LiDAR sensors, for example, can be very, very costly. So when it comes to cost, how much do you think this would be affordable, yeah, including your current sensors as well as what future sensors you're thinking about?
So currently, the sensors are pretty down to earth. They're not super extravagant or anything like that. The current cost of this device might be something around $30, if not less. Introducing the LiDAR sensor would definitely increase the cost of the device, and we're still kind of looking into whether or not the added benefits of the sensor would outweigh the costs or not.
Okay.
A quick question about the ultrasonic sensor. Can you comment about your detection range and also the field of view of the sensor?
Sure, the field of view of the sensor is a 30-degree cone. That's where it works best. But we kind of just pointed it straight out. It's adjustable at the bottom with the 3D printed attachment that we have, so you can angle it to be either further up or further down. Ideally, the way you hold your cane, you want it to be straight out, parallel with the ground. But the ultrasonic sensor works within the 30-degree cone. That's what it's rated for.
Cool, thank you.
Yeah.
Could you talk us through sort of the research you did to determine what cane users wanted and need for this project, or did you just decide this is what they need?
Yeah, sure. So we didn't, so due to kind of like the time constraints and the fact that we kind of only came up with the idea the day of, like yesterday, I guess, like the day of the hackathon, we weren't able to do probably like as much research as we would have liked. But one thing that we did is we did look at like what some existing, like we looked at some articles that talked about current challenges with you know, mobility for people that are visually impaired, and we looked at you know, some things that there are some like research projects that have been looking at like different things and like different sensors that could be used and different information in terms of providing, you know, like some kind of, you know, like navigational features or things like that. Yeah, but we didn't have time to like actually talk to, you know, people that are visually impaired or things like that, just due to time constraints.
Okay, and one follow-up. How much weight did you add to the cane, and does that become an issue if I'm on a prolonged walk holding it?
Sure. We don't have exact numbers, but just from us using it and testing, we didn't really notice that much of a discrepancy or that much of a um interference. Most of the weight is kind of carried up towards the top, so it's not like you're swinging around a whole bunch of weight towards the bottom of the cane. It's more so towards where you grip it, and you don't notice it as much.
And other than sharing audio in your presentation, what's something that went wrong during this project, and how did you get past that?
Oh man, this is a whole can of worms, like everything. One of the issues that we ran in towards the end is we compiled different parts of the code separately, and we noticed that we were running out of space on our microcontrollers, which neither of us have ever experienced before due to the mass amount of libraries that we were using. So we ended up using two different controllers, and each one had different functions, and they would communicate with serial with each other. That's how we got around that one, but that's just one to name a lot.
No, I mean, I can name also like another challenge that we ran into is with certain like APIs that we wanted to use. So like for example, the emergency text being sent to like the emergency contact and also the SOS feature. Initially, we planned to use like Twilio API, but it turned out that there's like certain restrictions with them of you like have to provide like tax information to be like a registered business to be able to send messages to, you know, like phone numbers. And then we also looked into like another service, but there was a certain like paywall behind it. So we kind of had to end up doing it ourselves of just doing SMS over SMTP. So a little bit like more bootstrapping, and you know, took a little bit of time of, you know, realizing that some things didn't work and had to pivot.
That's your time, guys.
Sure.
Thank you for presenting.
Thank you so
And
much.
Thank you.
Group 44, you guys are up next. You have 2 minutes.
Can you guys see our presentation?
Yeah, I'll give another minute, please.
Okay.
You just gotta make sure you get the picture of them. Oh, yeah, first. I think you should do the slides, or you were done. Maybe we can do slides in the middle. And then we can do it.
All right, guys. When you say go.
All right. We're ready to go.
Okay. Hello, we are Team MakeOHI, and for this Makeathon, we developed a device that assists visually impaired people, and we called it the DigiCane. Of visually impaired people, only around like 14% are completely blind. So we wanted to develop a product that could be useful for both them and people who have different levels of visual impairment. The traditional solution to this would be a manual cane. However, these can have issues in crowded areas, and they can have issues detecting objects that aren't entirely on the ground. And then also, while many white canes can be folded down when not in use, they're still bulky and they have risk of being lost if set down. So we wanted a better, more modern solution.
So we developed a product called the DigiCane, and it's meant to be used as a substitute to a traditional mobility product like the white cane. And this device is tied to your hand, whether that be as a glove or a clip-on implement. And this device measures the distance the user is from objects and communicates how close they are through haptic feedback.
Our prototype for the DigiCane utilizes a few key hardware components. First, an ultrasonic range sensor collects information about the surrounding environment, and then a vibrational motor sends feedback to the user, depending on how close an object has been detected. Our prototype is already small enough to be worn on the user's forearm and could be scaled down even further in the future.
And then additionally, we also put a camera on the user's chest and used YOLO V5's object detection AI model to detect what object is in front of the user, and it reads it to them through text-to-speech.
This part of our code is the main part of the software programmed onto the microcontroller. The ultrasonic sensor value is read first and then compared against a max distance value. And then that same distance measurement is again used to determine how much delay should be present before the next motor vibration. So if an object is close by, the vibration frequency will increase, and if an object is far, it will decrease. This on the left is a close-up of our device. The ultrasonic sensor is resting on the user's palm for easy and versatile use, and the vibrational motor is resting against the wrist so that tactile feedback can be given.
And this is also a photo of our object detection. The parameters we put on the model make it so that it only shows high confidence classifications, and it also doesn't overlap with other estimations, which makes the model only output a couple of detections, like shown here where it detects a bottle. And this will make it so that when we do text-to-speech, the user only hears the object they're looking at and not all the surrounding objects. And here are our demonstration videos. So in this one of our group members is wearing it on their hand with their hood over their face to simulate partial or total blindness. Sure. And so right now he goes and it vibrates so he can find the table, and then he moves his hand and it vibrates so he can find the bottle. And then additionally here, we spin him around so he sort of gets disoriented and he can find the table, it's sped up. He finds the table and then he's able to dodge the pole to there and then the trash can, and he's able to sit down and find the seat pretty easily. And then over here, this video is our object detection. And on the very right, you can see the output that it gets that we use for our text-to-speech. So it outputs what object it thinks it's seeing.
So the DigiCane's main application is to detect and announce objects in the surroundings, especially objects around waist height, such as tables or chairs. Visually impaired people may be able to notice the big objects, so the DigiCane picks up the smaller objects that they may miss. Our design is easy to create, mass manufacturable, and can have many different designs. For example, the DigiCane can be fit into a glove for elderly people or turned into a sort of Iron Man gauntlet for kids. In conclusion, the DigiCane has applications for people who have issues with traditional canes. The device is inexpensive and can be distributed on a large scale that is accessible for customers or consumers. Given more time and better resources, the DigiCane could be shrunk, given a better appearance, or be made more effective using a LiDAR light sensor instead of an ultrasonic range sensor.
Thank you.
All right, now it's the 4-minute Q&A.
That's an interesting project. So can you comment the challenge when you deploy AI on the edge? So especially what hardware do you use for running YOLO model, and what is the performance bottleneck you have encountered over the course of the project?
The YOLO V5 AI library is something that is just that we found online that was already pre-trained, so we don't have to train it ourselves with thousands and thousands of photos. And so we linked it up with Python, and then with another Python script that translates the output that it gets. Well, actually, the output is a CSV file. So we take that output and then find whatever max object it is, so that we determine what it's looking at, if it's keeps getting seen, and then we output it every second for text to speech. We don't have a proper camera right now. We couldn't have access to that. So right now we just do it every 1 second. But we think in the future we can connect it to the microcontroller so that when you get, like, for example, within 10 centimeters of an object, then it'll say the text to speech instead of just every second, because that is pretty annoying.
So just a follow-up clarification question. So is your YOLO model running on this wearable controller is always running on your laptop?
So right now it just ran out of the what's it called? The webcam on my computer. But again, if we had a computer, or a camera, we could have connected it to the microcontroller.
Sounds good.
Thank you.
2 quick questions. One is, do you guys know which TTS model you're using? The text to speech?
Python is PyTTSX3. That's the library that I imported.
Okay. And the second question I have is, so right now the sensor sense something that is at waist level or lower, right? So if you want to extend this to like objects at a head level, which are protruding or something like that, do you have any ideas of extending it to such a concept?
Yeah, so something that would also be like one of the main parts of the DigiCane that we did is so that it's in your hand, so it's really transportable. So if we could implement it on the head, it would be in the form of a hat, which it wouldn't be bulky because it would fit within the cap, and then it would detect things around head level.
So we had like sort of decision to make whether to try and make it waist level for like tables and chairs and stuff, or make it head level for like, so you don't hit signs with their head. But we thought since we were sort of digitizing a cane, that it would be more helpful at the waist level.
Yes, maybe you can also put sensors at the top of the hand or like edges of your fingers so that you can have a more holistic approach to the surrounding.
Yeah, one problem we encountered, or we were trying to figure out to put it on the palm or like the top of the hand to figure out which orientation would be the best to detect stuff, but we ended up with the palm. But it in the future, if we could develop it more, it could be on another part of the hand.
Okay, thank you.
Thank you.
So you said this is battery powered. How does the user know how much battery life is left? How often would they have to recharge it or replace the battery? Can you talk about that?
Right now in our hardware like implementation, we haven't gotten like any kind of like battery reader, but some ideas that we have for the future would maybe to make it just like a rechargeable battery that would be really lightweight too. Something that we noticed in our testing was like that the battery was really heavy, kind of wearing it down on like the forearm of the user. So something that we could do is like interface that also with the microcontroller. I don't think it'd be too expensive. For our testing purposes, we had just been using just a battery like clip on. So yeah, it's kind of like a limitation there, but we have like a lot of like hopeful ideas for the future.
And to announce the battery percentage, you could implement a sound system when it gets like below 20% or 50%, something like that.
But we were running it basically all day with like the battery we had, and like it never ran out. So I think it would be not a whole lot of use.
Extended battery life.
Thank you.
Thank you.
That's your time, guys. Thank you for presenting. And team 111, you guys have 2 minutes to set up.
Thank you, judges.
Okay, I think we're ready. Are we ready, Vishnu?
I'm ready. Well, are you guys ready?
I could start. I'll start the timer now.
Okay.
Okay. Hi, my name is
So,
Vishnu Nasiga,
and my name is Abshra Ali.
and we are in the AC 2260 class, and we worked in our project here, Arduino-based automatic trash can.
Okay, next slide.
Again, this is our team.
Yep. So the motivation of this project was basically, as you all are aware, automatic trash cans are generally pretty expensive. And the reason why they're expensive is basically because the sensors and the tools that are required to build the automatic trash cans are expensive to find. You know, the sensors and the other parts, they're all pretty expensive. And whenever something's expensive to build or expensive to process, the prices become expensive, right? So consumers will then become angry and they'll become frustrated because now they're being priced out of a product that can be really helpful for them. So we took that as a challenge because now we decided, okay, why don't we create a automatic trash can which can open up using motion sensing and dynamically tell you whether the content of the trash can is full or empty based on tools that were provided to us using the electronic kits provided to us during the MakeOHI. So that was something we challenged ourselves with, and we're going to discuss the product that we designed based on those factors. Next slide.
So here, our solution was an Arduino-based automatic trash can. It will open up when you move your hand in front of the sensor, or we use the ultrasonic sensor to sense motion, and there's a distance threshold. So once that distance threshold gets below 50, the sensor will prompt the servo motors inside the trash can to lift up the flap of the trash can. And then once you show your hand to the sensor again, the sensor will tell the servo motors to close the trash can. And these are all inexpensive parts that you can find at Micro Center or wherever at a hardware store, and without much cost. So here we will show our demo video. So this is our demo video, and as you can see, I put my hand out in front of the sensor, and that prompts the servo motors inside the trash can to open. And now I'm going to put my hand in front of the sensor again, and the servo motors close the trash can. Another feature that we added was to sense availability of space in the trash can. So this green LED, so RGB LED, so it can show R, G, and B. But we use this LED to showcase whether the trash can is available or closed. And that's showcased in the next video. So, sorry. So here, it's a little janky because I'm working by myself, but when the sensor, this sensor in the back right here is sensing our our height of the trash that accumulates. And basically, once I put this box over the sensor, showcasing that the trash has accumulated to where it's about eye level with the sensor, the red RGB light turns on. And when that happens, if I put my hand over our regular sensor, it will not when happens when I put my hand over the regular sensor, it will not prompt the trash can to open its mouth because it knows that there's no more space left.
Okay,
Those
Team
were the two videos.
111.
Thanks for listening.
Thank you for presenting. The Q&A time starts now.
A great presentation. Just a quick question for you. Just talk a little bit more about the application, talk a little more about the challenge you were trying to solve.
So the class is this is again, as I said, a class project, and so we were told to create a Makeathon project using 6 different components, and we used battery pack, ultrasonic sensor, and servo motors, Arduino, breadboard, and other components to create a trash can that will utilize all the different things we learned in the class. So we recently just this week covered sensors with the ultrasonic sensor, and then we had a motors lab where we covered servo motors and stepper motors and DC motors. And obviously we've been throughout the semester using the Arduino microcontroller to do our labs. And we had an RGB lab where we were testing the different colors of the single LED and trying to put different LEDs on there. And the battery pack, we've always used the laptop for battery, but this time we tried out with the battery pack also. And then for coding, we made this in the Arduino C. We're using the Arduino IDE, so showcasing our talent, our skills in writing the Arduino C code also. So all those things combined to do this project and to sort of show what we learned in the class so far.
Yeah, I can also add just a little bit for, even though we were doing this for a class project, obviously, one of the kind of intentions was also to kind of show that you can produce an automatic trash can which can open up dynamically based on the hand motion using parts which are inexpensive, right? So as I kind of mentioned, a lot of the trash cans which have those capabilities tend to be more expensive, and that will, sometimes they will argue that basically it's because it's hard to produce, but in reality, based on the tools that we've been given, we were able to produce at least a proof of concept that shows that it can be designed using simpler tools. So it's kind of trying to motivate us to potentially try to use more inexpensive parts in order to design something as complex as a automatic trash can, which can open up dynamically.
Thank you.
Can you speak a bit about how your sensors will deal with the environment? So it's a trash can. People have wet, sloppy things dripping off. They're throwing them at where your lid sensor is. They're dripping off their hands as they move it towards your sensor. So how susceptible are they to contamination?
We did not test for that specific those limitations and those factors, but one thing we can do better is currently we are only able to open up the lid of the trash can like a little less than, say, like around 45 degrees. We're gonna try to get that up to maybe 75 80 degrees, where there's more radius for people to throw their trash in, so that we don't have cut off some of the some of the sort of, I guess, obstacles that might come in front of our sensors. And we only using the one sensor for the outside, so we only have the hand sensor. So the trash height sensor is going to be inside the trash can. And that will hopefully make it sort of not susceptible to outside environmental factors.
Yeah, and I can also add a point regarding the ultrasonic sensors. Based to our knowledge of how these sensors work, they're pretty powerful in determining like whether whether there's motion in front of the sensor, even if they can be a little bit contaminated. You know, we were using those sensors a lot yesterday, and you know, it was basically being powered on continuously for a long time. You know, it was plugged into electricity for a long time, and it pretty much did not like have any damage. And in terms of contamination, we're not too aware of that because we didn't really use a lot. We didn't actually use actual trash. We're just trying to simulate trash being accumulated. So that's definitely something that could be worth investigating further if when we continue on with this project.
That's your time, Team 111. Thank you for presenting.
Thank you.
Team 10, you guys are up next. You guys have 2 minutes to set everything up.
Sorry, I'm trying. Oh, where's that?
Can you guys see that?
Yes.
Okay, cool.
Team 10, if you guys feel confident that you're ready, I can begin the timer.
Okay. Yeah, I think we're ready.
All right, I've started.
I'm Akshaya.
I'm Nikita.
And this is our Makeathon project. So we decided to implement a parking detection center. So basically, in our project, there are 3 LEDs, blue, red, and yellow. And so when an object is a little bit further away from the sensor, so like over 10 centimeters, the blue LED is on. And then when it's closer between 5 to 10 centimeters, the yellow one comes on. And then when it's really close, the red one will come on and a buzzer will sound. So in this video, you'll see the implementation of that. So there, you can see that. So when it's closer than 5 centimeters, that's when the red LED and the buzzer both come on.
Some of the components and the software that we used, we ended up using the SunFounder Mega Lab kit. And in this, we used the Arduino Mega 2560 board, the breadboard, 3 resistors, each of which were 220 ohms, a blue LED, red LED, and a yellow LED, a buzzer, ultrasonic sensor module, power supply, and the LCD 1602 module that we get in our kit, it isn't the best. It's not the greatest quality. So if we did have a nicer module, we would definitely use that, just so that it can display the distance between an obstacle and a sensor. And we also use the Arduino Sketch and Code to handle the logic.
So to implement this in the real world as a parking sensor, it would help detect any nearby obstacles that a vehicle gets too close to. So this would especially be helpful during parallel parking when there's multiple vehicles and pedestrians around. Because also with the different colored LEDs, it not only indicates like close objects, but also indicates how far these objects are. So in hours, the red one is for objects close in 5 centimeters, and then yellow is between 5 to 10 centimeters, and blue is over 10 centimeters away. But obviously, when we implement it in a parking sensor sense, we would use much larger distance ranges to make it a more practical solution. And so this could work by putting an LED display on the car dashboard, and then have those lights change colors based on the distance, and then also have a built-in buzzer to give a sound warning to the driver when they're extremely close to something.
Some of the advantages is enhanced safety. So by detecting nearby obstacles, the system improves safety for both the pedestrians and the drivers. It reduces the risk of collisions, especially in tight spaces, like during parallel parking maneuvers, where visibility might be limited. And the user interaction aspect allows for testing and ensures that the system is functioning correctly. And this simplicity makes it accessible to users of varying technical backgrounds. Also, while initially we designed it for parking assistance, the system can have broader applications such as in robotics for obstacle avoidance and or in home automation for monitoring spaces. Also, with real-time monitoring, the ability to detect objects at different distances in real time provides immediate feedback to the user, allowing them to adjust their actions accordingly, such as maybe adjusting their parking maneuver or stopping to avoid a collision. Thank you.
Thanks.
Thank you for presenting. Now begins the 4-minute Q&A.
Hey, good presentation. First quick question. How did you choose the LED colors?
So in the kit that we have the white, LED, red, blue, and a blue, yellow, and green. However, it just happens that our green LEDs were just not working. So we ended up with, otherwise we would have used the green instead of the blue. But if we were to implement this in real life, we would make it customizable so that the users can pick whichever colors makes it easier for them. If they have like red-green color blindness, they can choose more appropriate colors. But initially we wanted red to be, indicating like stop, so that, if they are super close to an obstacle, they can adjust their actions accordingly and stop. Yellow's for caution, and then green is obviously good distance. But because the green ones weren't working, we just ended up with blue.
Just a quick question. Once you do it in a more practical setting, like for a car, what different sensors would you be using? Like, what changes would you need to make to your project, do you think?
Yeah, Akshay, do you have something?
Yeah. So one thing would definitely be, as I mentioned earlier, with the distances, we'd have to have a sensor that can detect much further distances, obviously than like 10 centimeters, because in a real world, that's what we'd use. And also, when implementing in a real world, we'd make it more visually appealing for the user or the driver, so that when it's actually in the car, it would be like a different, maybe an LCD display, instead of having like the actual LEDs out like that.
Okay, thank you.
Yeah.
Did you look at any existing products on the market? Have you thought about developing this?
So I know like currently in a lot in cars, they a lot of them have like a buzzer sound, so when you get near objects it makes a noise to warn you. about that. And I think we did kind of use that with the buzzer concept in our project as well. But I think the LEDs helped make ours uh, a little bit different just because each LED indicates the distance of the object and not just that there is an object nearby.
So if we were gonna mount this on the car, where exactly would you think are the right places to mount it?
Definitely somewhere that it is easy to see. So we were thinking on the car dashboard display, if the car, comes in with like the built-in camera that you can see when you reverse, somewhere maybe above that, just so that it is easy to see the colors. That could definitely be one spot. Or we can also have it when in the display behind the steering wheel, where they talk about where it has like all of the miles per hour, the speed limit. We can also have it there as well.
And where should the sensors be, right? Are they above the bumper? Are they on the bumper? Are they below the bumper? Are they somewhere else on the car? Where would you physically attach that part?
I'd probably say that we'd have multiple sensors just so they can detect any possible objects around. So I'd probably say like probably on the bumper because I think that'd get the most range of motion, and then also on the back of the car as well, so that like when they're reversing, if there's any objects behind the vehicle as well, it could detect those too.
Thank you.
That is your time. Thank you, Group 10, for presenting.
Thank
Group
you.
113, you have 2 minutes to prepare.
Did you say group 113 or 13?
Hi guys, this is our team 113. Our topic is we build a RC car. My name is Puban Rao, and this is Jay, and this is Edwin. These are my group mates. So we were gonna explain to you more about our project. So the RC car, these are the components that we use: DC motor, breadboard, Arduino, battery, receiver, L293D chip, switch, wires, and joysticks, and yeah, that's it.
So in this project, we made use of the Arduino Uno board. We started using the Arduino Mega board, but we had some issues with it, so we had to switch to the Arduino Uno board. And then we used the L239D chip, which basically we used to run the motors, like control the speed and all that. And then we used DC motors, which Advait is going to explain.
So we used a DC motor to power the front two wheels to have the RC car move. And this is our RC car. So we had a Mega before, but we changed it to an Uno, as you can see in the video. We have a remote that allows us to send an IR signal to the car to have the wheels move. So we have front, left, right, and back, and stop. So the car's wheels moves. And one issue we faced was the IR would receive wrong data from like sunlight and other light sources. So we had to account for that. And if you have any questions, we're happy to answer them.
So you mentioned about using AR transceiver. There is some noise that can potentially impair the vehicle operation. So what changes can you make to prevent this interference?
We were thinking about switching from IR to Bluetooth, but we did not have time to switch.
Just a quick question. Like, did you guys look at what are the current models being used by other people, or like what has been done in this domain before, and how is your work different from such works?
We did not look at other people's works. We just wanted to create an RC car that would help visually blind people. So if we had sensors in front of it, we wanted to add AI so it could follow the person and give them guidance on if they should walk left, right, or forward, and obstacles.
Okay.
So could you talk more about the car? Is it four-wheel drive? Is it two-wheel drive? Why did you choose the choice that you made? What are the pluses and minuses?
We chose to do two-wheel drive because we weren't able to get enough current through the from the batteries to power all 4 DC motors.
Could you talk about your intended use case for the car a little bit more? So you said your intended audience was the blind. Could you talk about how it might work?
We wanted to use LiDAR to scan a room. So like for visually impaired people, they would know how big the room is and which ways to walk. But we weren't able to create AI models or anything. The RC car was as far as we got.
So let's say you'd had another 3 days to work, and so you could build the other part. You talked about the car being able to follow the person.
Yes.
Does that help the person though, or would it be more useful if the car could be in front of the person, seeing where they're headed, not seeing the back of the person?
We're having it in front of the person.
In front of the person, yeah.
So it would, for example, our use case was having a phone, and on the phone you could, so if you're walking forward, you would press the forward button, it would go ahead of you, and it would tell you how far away the stuff is. So if you had like an earpiece or something, it would give you audio inputs about how far stuff away from you. It should also be used to map rooms. So if you've already been in the room with the car, it would have been mapped already.
Thank you.
If we feel like we do not have any more questions, we can end Team 113's presentation here.
Yep.
Sure.
Thank you for
And
having
thank you
us.
for presenting, Team 113.
Thank you.
Next team up is Team 6. You guys are up in 2 minutes. Judges, I'm sorry I've not been checking up on you guys. Is the judging forms, am I giving enough time?
Yeah, it's okay. The time is enough.
Making it.
Time has been.
right, sorry again. And team 6, do share your slides. All right, team 6, when you feel you're ready, say go and I'll begin the timer.
Hello.
Oh, yeah.
Can you hear us?
Yeah.
We are team 6. Just go with it.
I'm trying to fix it.
We're team 6, and we made a tracking smart security camera. And the goal with this was that your camera, it'll be a cheap.
What up? There we go. Sorry.
I'm Max McGee.
I'm Gage Lilly.
I'm Matthew Weichel.
And our other teammate, Sana Z, wasn't able to be here, but our features was to track an individual who's within the view of our security camera that is unknown by your system, so that if a suspicious individual is there, you can follow them within a 180-degree field of view. This is some of our project code. We, in Python, used OpenCV to find a face within a video capture, and then it draws a box around the face, and then it finds the centroid of that box, and if it's not within the center, over serial, a code is sent to the Arduino, and then the servo will turn, and then it'll check again until the face is within a certain range on the inside.
And then we ran a data detection script where the camera took pictures of the face and stored it into a file. And then we ran a training algorithm that would train the system whether or not it knows the face. And then we draw a box on the face and label that it's a known face or an unknown face.
We will now do a live demo of
Should I just start video?
No, hit resume.
Well, I'm sharing a certain screen.
New share.
Yeah.
Discord. Is this gonna work? Can you see this?
Yes, we can see it.
Okay, so that goes to sit in the middle. So this is the model. Matthew's our known individual, so if he moves, the camera's not gonna follow him, but Gage is unknown. Oh,
wait, because I didn't see. Matt, go back in. Like, get a good view of your face.
yeah. Now, if Gage comes in to frame, the camera will start tracking him because he's unknown. And oh, it thinks you're Matthew. But yeah, so when it detects that he's an unknown individual,
Confidence isn't that high.
it'll track him. And then alongside this, we created a web page that is password protected, that has a live feed. What's the password again? That has a live feed to the webcam. So on your phone, you would be able to see what your camera is tracking. And features that we eventually want to add are notifications to a phone and when there is a unknown presence detected on the camera. So is it the Chrome? So the impact is we wanted to make a cheaper alternative to some security cameras by using a simple servo and having having a computer handle the computation and then sending it to a microcontroller can decrease the cost of having an expensive microcontroller in your camera. It's customizable to what the user needs, so you can upload as many faces that would be recognized. There's live footage, and then multiple cameras could be used.
No. So the user experience for this is very simple. It's essentially plug and play. If it was to go to market, it'd be plug and play. So you could just import your data of your face, have it trained so it knows who you are, and then you could just plug it in and be running from the start. And it's customizable because you could use whatever webcam you want. You can put it on any device that you want, and then you can use any camera that would be universal with it.
And that's all we have.
So real quick though, I want to show them the camera actually moving.
Oh, okay.
So if we move our webcam off to the side. You can see the webcam following him as he moves.
It moves pretty quickly.
So yeah.
Obviously, moving forward, one of our next steps would be to create a better enclosure, so it's more market ready.
Yeah. So, are there any questions?
That was your time, guys, and the questions time starts now.
So if I'm thinking of this from a security point of view, you say it'll track if it doesn't recognize the face. What if
Yeah.
you're too far away for it to really tell the face and whether it knows it or not? Will it track that individual until they're close enough to tell?
OpenCV has libraries to track bodies. We found that it was a little glitchy with our setup, so we could try and find a better model for like body tracking, and we could set it up so it tracks both a face and a body.
And it also comes down to the it also comes down to the camera specifications because some cameras have more zoom that would be able to detect faces from farther away. In our case, the detection the range is kind of shallow because we're using a wide-angled GoPro. So if we were to use a higher quality camera, it'd be able to detect from a farther range.
And potentially, could a bad actor use this intentionally to distract the camera by pulling it to track them so someone else can sneak past it?
I mean,
Yeah. The goal is to cover a wider range than you could with like, there obviously are 180-degree cameras, but they're expensive and they're harder to get working with like facial recognition stuff. So where if you were to have a camera that can detect faces, it doesn't have the 180-degree view. So with this one being able to track, if somebody was able to like find a blind spot in the normal camera, this might have blind spots with the pull, but I feel like the pros outweigh the cons on that one.
Thank you.
Hey, I was just really quickly wondering, what made you decide to go in this particular direction? There are cameras out there that track pets and things in the house. So what drove you to implement this particular feature?
Well, one thing is all of us are going to be living like off campus next year, and our friend in the group Sana was like brought up the idea of like safety and living off campus. So we wanted to like make something that it's like cheap and affordable for college students and gives them like a feeling of safety in their homes.
And it would also be simple to combat the bad actor in that situation, to have the camera follow a certain individual at each time. So if she was like afraid of like something happening at night, to be able to follow her all the time to see what's going on at the end and be able to store that into a database.
You talked about maybe an app or something like that. Could you talk about if you had more time, what you would do to improve that or this project?
Yeah, so one thing's for sure is we want to have the video actually showing the facial detection, but because of Ohio State's Wi-Fi and the port forwarding protocols, we weren't able to do that. We also wanted to make it more compact so it could be put somewhere, run off a certain device. Once again, Ohio State port forwarding protocols like made that very, very difficult.
Yeah, we attempted to upload the facial tracking code to a Pi, but we didn't have a Pi 5. So it ran too slow before the person would be able to like get past before it caught up. So there's just like hardware limitations right now.
We also wanted to add into the database, so it would take a note of each different face that it sees and store that. And if it sees the face in a certain amount of time, it would recognize that that's a regular person that like comes. So let's say it's like if it's like approved, so they could be added to the database too without being trained. And then build a better enclosure. Also, we'd want to be able to use a stronger motor so you could use different like weighted webcams and cameras.
And that's time for the Q&A. Thank you, Team 6, for presenting.
All
Thank
right,
you.
thank you.
And this is where the recording ends, unless do the judges have anything to say? If not,
One
good job.
question, wasn't there,
Oh.
there was one more team on our list? Did they not finish and submit?
What team was this?
Well, it says 109 Sleepy, but in my list, 108 is Sleepy and 109 is a different team, so I'm not sure what that means.
I believe they were removed. They are no longer on the list I was given.
Okay, because I see someone from Team 109 is in the room in Zoom.
I mean, I'm pretty sure we did. It's Team 108, not 109. I said we
108.
did submit a slide though for the Neuralink challenge.
Are you sure you're supposed to be in this breakout room and not breakout room 5? Were you for Intel submissions?
No. It says on the list that Team 109 is supposed to be in breakout room 3.
We were Team 108 though.
You're Team 108, but Team 109 is supposed to be here.
I think we're Team 109.
No, on the Discord it says for Team 108.
Are you two in the same group?
Yeah.
Yeah, but we are Team Sleepy. It says Team 108 on the Discord and then Team 109 on that.
Team 108 is supposed to be in group 5, room 5.
Should be
If
good.
you guys can go there.
So we're in group 5, Ben?
Yeah, I'll message the moderator for that. Thank you for telling me.
Did we get team 113 actually?
Yeah, you guys presented earlier.
Is room 5 the Intel submissions?
Yes.
Was that for people who were doing the Intel challenge or doing?
Are you guys doing the Intel challenge?
No, we just did like a general project.
Just did a general project. I'm messaging the moderator for team or for group 5. I'll get back to you.
On the list that was shared with us, there are two 109 teams. I think there might be confusion with that because 2 teams are called 109 there.
I think you're right, Judge Anwesh. I'm meeting with that moderator. I'll be back in 3 minutes.
By the
everyone.
way,
Sorry.
I just want to clear it up. We did not do the Intel challenge. We just did like a general challenge just for fun.
I'll let them know. Give me 3 minutes. Sorry. Uh, I just received news the judging for that the yes, the Intel judges have left. Are the judges here okay with this group presenting?
Yeah, it's fun.
Yeah, I'm fine with that.
Thank you. Thank you, everyone. Team 108, you can present you have 2 minutes to set up.
We're already set up. We just have to share our screen. You ready, Ben?
Yep. Also, we did not do the Intel challenge. We're just the like regular MakeOHio challenge.
All right, I can
Okay,
start the
see
timer.
screen. Okay, so what we did was basically a nerf like a nerf auto fire. We were originally gonna do like a on a gun like nerf gun that adjusts its angle like on unsteady surfaces on a drone, but we were not able to finish in time, so this is what we were able to get done. It's not. Yeah, explain components, Ben.
Sure. So some of the components that we just used like the basic Arduino MCU as our microcontroller, and then we used a servo motor. This is what we used to actually like fire like the Nerf gun when it like sees that there's a target in front of it. It's just a simple servo motor that pulls the Nerf gun's trigger. And if you go to the next slide, this is just the breadboard we used for like circuit connections. Next slide. So this is what we used a joystick to control like the angle that the Nerf gun fires at. So the current version that we had is that you can move the joystick left and right, and it'll aim the Nerf gun left and right. If we had some more materials like wood or like plastic to build like a better structure for the Nerf gun, we could have it like aim up and down. This is like the easy way for it to be like remote controlled, and it also just makes it a lot easier to use. Next slide. This was our sensor for like detecting if it was a target in front of it. So we just used a simple ultrasonic sensor. We could like set the distance of when like targets come into within a certain range that like the Nerf gun fires at it. Next slide.
Originally, we were going to use like a camera sensor, but we didn't have like one of the components on hand. So we switched to a sonic sensor for the Nerf gun.
So this is our schematic diagram of like how our circuit works. So we have the stepper motor, we have an ultrasonic sensor, servo, and a joystick. And what's not shown on here is that we used our laptop as a power supply. In the future, if like we were actually going to make this an actual design, we would use just like a battery so that we didn't have to have the laptop go along with it.
So this was basically the final product, I guess. Well, what we finished. This is like a demo. but no, like it's gonna show up here, but the entire left side of the Nerf gun has like duct tape on it, so you can't actually press it from the left side. Just warning you ahead.
And so like this like platform here being moved by the motor, we didn't have like the like strong enough materials to actually hold up the Nerf gun, but it was more of a proof of concept of if we had like I don't know, like 3D printed like plastic or like some like wood to cut out, we could have that motor like adjust the platform the Nerf gun's on so it could be used almost like a turret.
Okay. So at the end, I was just saying that we weren't able to like finish because like we didn't have like enough materials on hand.
Yeah, so some of the future work we were considering doing is we'd obviously combine all of our components together. We sort of had everything as kind of like a mishmash, everything working like individually. But if we had like some better like structural support, we could combine everything together. Some better cable management would be good. From our schematic diagram, a lot of our cables were crossing with each other, and it meant that the Nerf gun couldn't move too much without some of the cables coming out. We were also thinking if we had a like a compatible camera that we could do like a targeting system. So if like you were like playing a game or something, you could have a red team and a blue team, and that this like Nerf gun would only shoot at like players on like the blue team. We were also going to have like the Nerf gun auto reload, but we just needed a stronger motor for that.
We originally had a like a motor that did the reloading. It would have worked, but the only problem was it was a servo motor, and that was barely enough strong enough, and it did not like turn more than 180.
That's
So
your time, guys. Thank you for presenting Team 109. The Q&A begins now.
Just a quick question. So right now the targeting is based on distance, correct? From what I
Yes.
understand. What
Yep.
exactly is the distance threshold? Do you guys know that?
We could set it to different values using the ultrasonic sensor. Right now, it worked best when it was very close, just because the ultrasonic sensor isn't very strong. But it could work from a decent distance away. But we found that if it was too far, like too big of a distance away, that sometimes things like the table shaking would cause the Nerf gun to fire. So we set it to a shorter distance to make it more consistent.
Okay, so basically to change distance, you would probably need to use a different sensor then?
Yeah.
yeah, probably a stronger one.
Okay.
And
Yeah.
we were thinking of like actually if we had more time to change out the sensor with a camera, so that we could use like some sort of computer vision model to like if you had like a game and you had like a red team and a blue team, we could identify like which like targets were on the blue team, and then the Nerf gun would only fire at like blue targets.
Originally,
got
we
it.
were planning to use an inbuilt like library for the EP32 camera module. But then we couldn't if I like we have a camera module like board on hand. We have the camera, but not like a board that lets you like take continuous video.
Okay, thank you.
You had mentioned designing this to attach to a drone potentially. So how much does all of it weigh if you had put it together and had it functioning? How much weight would you be adding to the drone to do that?
I mean, it would mostly just been the gun itself, which doesn't actually weigh as much as it seems. The camera module, which is also pretty light, and another 3 servo motors. The drone's actually pretty strong, so it would have like had an impact, but it still would have been able to fly like a good distance up and down. That answer the question, or?
Yeah. On a second thing, you came into this sort of knowing what was there. So in hindsight, how would you change the scope of your project to better fit the time and resources available?
If you had like given more foresight beforehand, we probably would have like tested out the camera module beforehand. We just knew like what materials we were gonna have on hand, and we just assumed it was gonna be enough. And also, we probably should like made the scope a little smaller, so we tried to do everything at once. We probably should have just focused on like getting the gun to like move up and down and left and right, and planned for that. Ben, anything else to add?
No, that should be good.
Thank you.
Any other questions? I think that's the end of questions then, right?
So what drove the team to explore this space?
I mean, this project idea.
Yes.
So originally, the original idea was to make like a AI like Nerf gun drone. I mean, we just did it because with the emergence of like AI technology, it'd be fun to do an AI project and want to like a basic we had another originally we had a third member who was taking a computer vision class, but he was not able to do the makeathon because he had things come up. So we were planning to do something with the vision, and we had like a drone on hand, and we thought it'd be cool to make a gun drone. And the inbuilt libraries have like very simple code to actually identify objects. So we were just thinking like if it detects a certain something or like a someone, because like the vision library inside the camera module actually identifies it for us with like maybe like 60% accuracy, I think. Like a decent amount of accuracy. You can tell it can sometimes like confused with like a red ball and lemon, I believe the tutorial said. So we were planning to have like a drone like using AI to like fly around and like find someone and like adjust the gun by itself to shoot someone with a Nerf gun.
All right, thank you, Team 109, for your presentation and Q&A. That should be the end of this list of presentations. Thank you, judges. And I'll stop the recording now, unless anybody has anything to say.
Just a quick question to the moderator, to you. Like, is there anything else on our part that we need to do?
I
For the
believe you
judges?
guys have to finish the submission, the forms, and that's all. That's all.
Okay, thank you.
Thank you. All right, I'm ending the record, and everyone is able to